Hi everybody, I hope you guys are all doing well. You should be watching this on Fridays, so I hope you guys are all excited for the weekend. Today we're going to be talking about how to solve a rational equation. And a rational equation is any equation that involves a rational expression. Okay, so it has to have a rational expression in it, have an equal sign. We're going to solve for the values of x that satisfy the equation, that make the left side equal to the right side. Now, before we do that, I want to just look at, this isn't quite a rational equation, but another equation. So I'm going to write something down here. Here's another equation, and we're going to solve this. Okay, now this is not rational because there are no variables in the denominator. So these expressions that have an x in them are not rational expressions. This is actually a linear equation. Okay, and so when we usually solve linear equations, what we do is we collect all of the terms with x on one side and collect all of the terms that are just numbers on the other side. And then we can divide by the coefficient of x and solve for x. Okay, so usually that's the way that we do that. And we could totally do that with this one too. However, we could also make lives a lot easier for ourselves, make things a lot easier for ourselves if we eliminate all of these denominators. And we can do that in an equation because essentially this equal sign is acting like a fulcrum, right? And as long as we do the same thing to the left and the right, then this equal sign, this equality has been maintained. And so we have the ability in an equation to eliminate all the denominators. Okay, so in this equation, what we could do is multiply everything by the LCD. Now, if you look at the denominators that we have, 3, 4, 6, and 2, the LCD of all of those is 12. So what I'm going to do is I'm going to multiply everything by 12. So times 12, times 12, times 12, times 12. Okay, now with numbers, what's nice is, and remember this is like 12 over 1, maybe I should do that too, is that everything cancels. So I'll take the extra step here. Some of you might be able to do this in your head, but the next line would be 12x over 4 minus 12 times 2 is 24 over 3 equals 5 times 12 is 60, so 60x over 6 plus 1 times 12 is 12 over 2. Okay, now all of these fractions are going to simplify to whole numbers. So that becomes 3x minus 8 equals 10x plus 6. Okay, so what I have done going from here to here is I have sort of transformed this equation into a linear equation that involves fractions and denominators to one that doesn't. Now what I can do is I can collect my x's on one side, collect my numbers on the other. So perhaps I'll move the 3x over here and I'll get negative 8 equals 7x plus 6. And then I can subtract the 6 and I'll get negative 14 equals 7x, and then divide both sides by 7. And it's actually a miracle that this worked out to be a whole number because I totally just made this equation up on the spot, but there you have it. X equals negative 2. Okay, now because this is linear, we could have solved this without doing that, without multiplying by the least common denominator, and then we'd have to deal with everything in fractions, but it gets a little messy. But we do have that option because it's a linear equation. Okay, now with rational equations, this LCD is going to become very important. Okay, so that's what we're going to talk about today. All right, over to our notes. Do I need my Wi-Fi data? I don't think so. All right, there we go. Rational equations. All right, so step 1, factor everything. Step 2, MPVs. So that is standard. Step 3, multiply each term by the LCD. Now, that is something that we just did, okay? So these two, oh, whoops, sorry, I didn't put on the pen. Okay, these two guys are what we do for all rational expressions. We have to factor and state non-permissibles. Multiply each term by the LCD. Well, we just did that. Okay, now what we're going to see is that this is going to transform when we multiply by the LCD. This step changes the nature of the equation. It's going to transform it from a rational equation into another type. And the other type that we're going to see in this course is either linear or quadratic. This step here will change the equation to linear or quadratic. Now that's nice because we know how to solve that, which is what we're going to do in step 4. Okay, we're going to solve it. Okay, what we have to think about though is this. Linear and quadratic equations do not have any restrictions on what the solutions can be. And so when we solve this resulting linear quadratic equation, once we eliminate this LCD, we may get a solution that happens to be a non-permissible value. And if we get a solution that's a non-permissible value, we have to throw it out. It has a special name. It is called an extraneous root. Okay, and it's got to be checked out because it will not satisfy the original equation, which is in fact rational. Okay, so we're going to start small. The first one we're going to start with actually is like the one we just did, not a rational equation because there's no rational expression here. Okay, there's no variable in the denominator. This is actually linear, okay? But again, if we multiply everything by the LCD, makes our life a lot easier. In this case, our denominators are 6, 1, and 3. So between those three denominators, the LCD here is 6, okay? Now, because there's no variable in the denominator, we do not need to worry about non-permissible values. So that's kind of nice, but we can go ahead and multiply everything by that LCD of 6. So I'm going to multiply everything by 6. Okay, and what happens is that my denominators will cancel. So here, these completely cancel. And what I'm left with is a minus 2. Here, the 1 doesn't cancel with the 6. So I just have minus 5 times 6, which is 30. And here, 6 over 3 is the same as 2 over 1. So that cancels to a 2. So I have 2 times a plus 3. Okay, so I still have a linear equation, but now this linear equation doesn't have any denominators, which is quite nice. Okay, so I can distribute here. And I'm going to have, maybe I'll simplify. So this is going to become a minus 32 equals 2a plus 6. Okay, and I'll subtract a. So I'll have negative 32 equals a plus 6. And then subtract 6. So I get that negative 38 equals a. Okay, so simple example, and in fact, this one is not actually a rational equation, but it does show the process, okay? We didn't really have to take care of the non-permissible value though, and we didn't have to think about these extraneous roots. Okay, let's see what this would look like when we do have to think about perhaps non-permissible values and extraneous roots. Okay, so here we've got another one. We've got x minus 1 over 3 plus 4 over x equals x over 3. Okay, so luckily everything's factored. That's nice. We don't have to do anything there. Our LCD, I've got a factor of 3 here, x here, and 3 here. I don't need to repeat that factor of 3, so my LCD is 3x. Okay, so what I'm going to do, I don't have a lot of room here, so I'm going to spread out a little bit, rewrite this. Hold on. Let me do that again. So I'm going to have x minus 1 over 3 plus 4 over x equals x over 3. And what I'm going to do is I'm going to multiply everything by this LCD of 3x. Oh, you know what I forgot to do? I'll do that right now. I forgot to do my non-permissibles. Okay, so non-permissible value, x cannot equal 0. There we go. Okay, now once I multiply by this LCD, all of my denominators will cancel. So from this first term, the denominator of 3 will cancel. From the second term, the denominator of x will cancel. And from the third term, the denominator of 3 will cancel. And if I look at what I have left to go on my next line, from this first term on the left, I've got x times x minus 1. From the second term, I've got 4 times 3. And then on the right, I've got x times x. Okay, so what I need to do here is do some expansion and then solve and see what type of equation I have left. Okay, so I'm going to have x squared minus x plus 12 equals x squared. If I subtract x squared from both sides, okay, the x squared term actually goes away. So I'm going to have, this actually becomes linear. Negative x plus 12 equals 0, which means that x equals 12. Okay, now what I need to do is I need to check this. Check to make sure that your answer is not a non-permissible value. Okay, the answer is not 0, so this is okay. This is the answer. Okay, all right, let's do a couple more. Here we go. X minus 12 over x plus 3 equals negative 2. Well, doesn't look like these two terms, x and negative 2, have denominators, but they do. Their denominators are 1. Okay, so between these three denominators, I've got a denominator of 1 and a denominator of x plus 3 and then another denominator of 1. My LCD there is x plus 3, right? And by the way, everything's factored, so that's nice. I don't have to worry about that. My non-permissible value is x cannot equal negative 3. Okay, so what I'm going to do again is I'll rewrite this out. And I'm going to give myself some space so that I can go ahead and multiply everything by that LCD. And then I'm going to see what cancels. So I've got to multiply this by x plus 3. I've got to multiply this by x plus 3. And I've got to multiply this by x plus 3. Okay, now from the first term, nothing cancels because my denominator is just 1. For my second term, these cancel. And from the term on the right, the negative 2 over 1, again, nothing cancels because the denominator is 1. Okay, so on my next line, what I will have is x times x plus 3 minus 12 equals negative 2 times x plus 3. And in this step, I have changed the nature of the equation. It is no longer rational. Okay, it is either linear or quadratic. This one, when I expand here, it looks like it's going to be quadratic. Okay, so I'm going to expand and simplify. I'm going to have x squared plus 3x minus 12 equals negative 2x minus 6. And this one is in fact quadratic. So I've got to equate one side to 0. I've got to add 2x and add 6 to both sides. Okay, so I'm going to have x squared plus 5x minus 6 equals 0. And this one's factorable, so that's quite nice. So I'm going to just continue this over here because I'm running out of space. I'm looking for two numbers that add to 5 and multiply to negative 6. And those numbers are 6 and negative 1. Whoops, I was thinking too fast. I was speaking ahead of writing. There we go. X plus 6 and x minus 1. Okay, those two numbers will add to 5 and multiply to negative 6. And from the factored form, I can see the solutions to the equation are x equals negative 6 or 1. Okay, so now what I have to do is look at my non-permissibles and check. And my answers of negative 6 and 1 are not the non-permissible value of negative 3. So both of these are valid. These are both valid answers to this equation. Either of those x values will make the left side equal to the right side. Okay? All right. Let's try another one. We do have some factoring to do here, finally. Okay, let's do it. So on the left side, there's no factoring to do. That's nice. We've just got 9 over y minus 3 minus 4 over y minus 6 equals, I should spread out at the same time so that I can, on the same line, multiply by the LCD. 18 over, let's see, I'm looking for two numbers that multiply to positive 18 and add to negative 9. And I believe those numbers are negative 3 and negative 6. Okay, so my LCD is I have to have at least the y minus 3 times the y minus 6 from the denominator on the right. But then if I check each of the denominators on the left, I've already got the factor of y minus 3, and I've already got the factor of y minus 6. So this is my LCD. Okay, my non-permissibles, y cannot equal 3 or 6. Okay, now I can go ahead and multiply everything by that LCD. So I'm going to just kind of squish it in if I can, so I don't have to rewrite this whole line. Okay, and here, y minus 3 times y minus 6. Okay, and then denominators will cancel. So from the first term on the left, the denominator of y minus 3 will cancel with this factor. And from this second term, 4 over y minus 6, the denominator of y minus 6 will cancel with this factor of y minus 6. And on the right side, the entire denominator will cancel with that. So if I take a look at what I have now, I have 9 times y minus 6 minus 4 times y minus 3 equals 18. And now I have to do some expansion and some simplification. I think this one's going to be linear. So I'm going to go ahead and do that. So I'll have 9y minus 54 minus 4y plus 12. Be careful about that, right? Because negative 4 times negative 3 is positive 12 equals 18. So that gives me, let's see, 5y, and then negative 54 plus 12 is negative 46. Is that right? I think so. No, wait. Why can't I do math today? 54 minus, let me think about this. 54 minus 12. No, 42. Yeah, that's better. Sorry about that. Equals 18. There you go. And there we go. Now we have to add 42 to both sides. Okay. So we're going to get 5y equals 42 plus 18 is 60. That's a little better. Although the answers don't have to be whole numbers, but if we divide by 5 now, we're going to get y equals 12. And the thing that I have to do now is check here. Right? Is that a non-permissible? No, it's not. So this is good. Okay. Okay, I think we're going to try 2 more. Here's the next one. 3x over x plus 2 minus 5 over x minus 3 equals negative 25 over x squared minus 6 minus x minus 6. All right, so we got a factor. We have a little bit of factoring to do here. Let's do it. Nothing to factor on the left. I'll leave myself some more room this time. Equals. Okay, on the right, I do have to factor. Negative 25 over, looking for 2 numbers that multiply to negative 6 and add to negative 1. And if you're having trouble with this, often, at least one of the factors will be one of the other denominators. So that's a good place to look. And yes, in fact, that's true. The 2 numbers are negative 3 and positive 2. Okay. So here, similarly to the last example, the LCD will be x plus 2 times x minus 3, which means the non-permissible values are x cannot equal negative 2 or 3. Okay, let's multiply by that LCD, see what happens. Oh, I'm sorry, I made a mistake. This should be 3x. That's better. Copying error. Okay, fixed now. All right, let's now multiply by that LCD. So I'm going to multiply by x plus 2 times x minus 3, x plus 2 times x minus 3, and x plus 2 times x minus 3. And now the fun canceling begins. So here I can cancel the x plus 2's, here I can cancel the x minus 3's, and here I can cancel everything. And if I take a look at what I have left, I've now transformed this into a different type of equation. I have 3x times x minus 3 minus 5 times x plus 2 equals negative 25. Okay, so to solve, I've got to do a bunch of, again, expansion, simplification, see what type of equation I have so I can see what I need to do to solve. So I'm going to do that next. All right, here we go. 3x times x, 3x squared, minus 3x times 3, negative 3 is 9, minus 5x minus 10 equals, oh, sorry, this should be 9x. There we go. Whew, negative 25. I need you guys with me to catch my mistakes. Okay. And it looks like this is quadratic. So I'm going to bring everything to one side. Okay, so equate one side to 0. Okay, so here I have 3x squared, and then negative 9 minus 5 is minus 14x. Negative 10 plus 25 is plus 15 equals 0. Okay, so if I do, let's say maybe a decomposition here, I'm looking for two numbers that multiply to 3 times 15, which is 45, and add to negative 14. And I think those numbers are negative 9 and negative 5. Right? Because 9 times 5 is 45. So the negatives would be also, if you multiply the two negatives together, you're going to get 45 as well, and those add to 14. Okay? So if I did a decomposition, I would have 3x squared minus 9x minus 5x plus 15 equals 0. And then I can factor GCF out of the first two terms, which is 3x, and I'm left with x minus 3. And then I can factor out the negative 5 out of the last two, and I'm left again with x minus 3. I'm running out of room here. But that's going to make, I have this GCF now of x minus 3 times 3x minus 5 equals 0. Okay, so that's the factored form. Now, from that, I'm going to come up here. Well, from the factor of x minus 3, I'm going to get x equals 3. From the factor of 3x minus 5 equals 0, I get 3x equals 5, which means x equals 5 over 3. So I have this, and I have this. Okay, now what I have to do is go and check here. And what I can see is that one of my solutions is one of the non-permissibles. And so this guy needs to be eliminated. Okay, this is called extraneous, because this solution of x plus x equals 3, it works in the resulting quadratic equation. Okay, it satisfies the resulting quadratic equation when I eliminate the denominator, but it does not satisfy the original rational equation. And so it's called extraneous, and we have to throw it out. This is the only answer. Okay? All right. Last question. Okay, so factor. Okay, factor. So we have something to factor in the denominator. We can factor this into a difference of squares. Okay, there we go. Now LCD, non-permissible. So the LCD looks like is x minus 2 times x plus 2, because that takes care of the first denominator, and then the factor of x minus 2 from the second denominator is already taken care of. So that's our LCD. Okay, now we can go ahead and, oh, non-permissibles, sorry, forgot about that. X cannot equal 2 and negative 2. There we go, that's better. Now we can go ahead and multiply everything by that LCD. And so when I do that, some nice stuff will cancel. So on the left side, I should put brackets around here actually. The entire denominator will cancel. And on the right side, the x minus 2's will cancel. So if I take a look at what I have left, on the left, I'm going to have 3x minus 2. And on the right, I have, well, maybe I'll just, because this is a simple one, I can expand at the same time. 4 times x plus 2 is 4x plus 8. Okay. All right, so now to solve for x, got to bring the x's on one side and the numbers on the other because this is a linear equation. So I will subtract 3x from both sides, and I'll get -2 equals x plus 8. And then I could subtract 8 from both sides, and I get x equals -10. And what I now need to do is check there. Okay, and I can see that that answer of x equals -10 is a valid answer because it is not a non-permissible value. Okay. The other thing I should mention, I didn't actually demonstrate this, but we have done this for other types of equations in the course, is that you should verify and can verify your answers by putting them into the original equation, right? So I'll just maybe verify this one. If you wanted to verify, right? Take a look at the left side. The left side is 3x minus 2 over x squared minus 4. Okay, right side is 4 over x minus 2. So if I plug in a -10, I'm going to get 3 times -10 minus 2 over -10 squared minus 4. The right side would be 4 over -10 minus 2. And I keep sort of simplifying, right? So this guy, 4 over -12, is -1/3. Okay, this one is going to be -32 over 10 squared is 100. 100 minus 4 is 96. -32 over 96 is also -1/3. So we have left side equaling right side. Okay, so you can also check your answers that way to make sure that your answers are correct and you haven't done any algebra incorrectly. Okay, so you got to check your non-permissible values. This verification process is optional, but it's a good idea because it can you can be sure that your answer is actually correct if you verify in this way. Okay, so I'm going to stop here today. Tomorrow, or not tomorrow because tomorrow is the weekend, on Monday, we will look at applications of rational equations and complete the rest of this work.